Chapter 11 is about sequences and series. So make sure you know how to write an explicit formula and recursive formula for both types of series. So in this case, or sequences, in this case, excuse me, I can tell that the numbers are going down by 3, so the common difference is 3, which makes it arithmetic. So the explicit formula is going to be a sub n equals the a sub 1, which is the first term, plus parentheses n minus d, or n minus 1, times the common difference. So I'm going down by 3, so this is my explicit formula. So the explicit formula lets you find the 10th term, the 100th term quite easily. So if you use the recursive formula is 2 lines. So whenever you have a recursive formula, you need to know what the first term is. So the first term is 48, and then to get any term, you're going to take the previous term before it, or the previous term. So that's going to be n minus 1. n minus 1 always represents the previous term, and you're going to subtract 3. So if I generate the sequence, I'm going to start at 48, and to get the next term, I'm going to take the previous term minus 3. So 48, 45, 42, etc. So it works. To find the 100th term, you're actually going to want to use the explicit formula, because to do the recursive formula, you'd have to figure out the 99th term. So I'm just going to plug in 100. So a sub 100 equals 48 plus 100 minus 1 times negative 3. So I put that in my calculator. 48 plus parentheses 100 minus 1 times negative 3. Just make sure you don't subtract 3 at the end. So this is negative 249. To find the missing terms of a geometric sequence, so a geometric sequence has a common ratio. You're going to want to find the geometric mean to get the middle term. So the geometric mean of 20 and 80, you're going to take the square root of 20 times 80. So square root of 20 times 80 is 40. So has to be a positive 40, because the sequence is either going to go positive, 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 or it could go positive, negative, positive, negative, positive. So either way, this has to be a positive 40. Then I'm going to find the geometric mean of 20 and 40. So square root of 20 times 40. So square root of 20 times 40 is going to be the square root of 800, and then I can reduce that. So since the square root of 800 is the square root of 400 times 2, this is going to be plus or minus 20 root 2, because the square root of 400 is 20. Same thing with doing the square root of, or finding the geometric mean of these two. It can be a positive or a negative. This is going to be 40 root 2. Okay, so make sure you put the plus or minus for that geometric one. Evaluate the series. Whenever you read evaluate the series, you need to use some type of formula, whether as long as there's more than a few terms in the sequence. So a series is a sum of a sequence. So this one happens to be an arithmetic series, because if you generate the first few terms, let's plug in n equals 2 to get the first term. We're going to get 3 times 2 minus 7, which is negative 1. Let's put in negative n equals 3. That's going to be the second term, because I'm starting at n equals 2. So n equals 3 is going to be 9 minus 7, which is 2. And then I plug in n equals 4. So it's 3 times 4, which is 12 minus 7, which is 5. So I can tell this is arithmetic because it's going up by 3. So to find the first term, we did that over here. The first term is plugging in the bottom number. So the first term is negative 1. And to get the last term, you want to plug in the top number. So the last term is going to be 15 times 3 minus 7. So 15 times 3 minus 7 is 38. So the last term is 38. So to get the number of terms, I'm going to take the top term minus the bottom number, or top number minus the bottom number, and then add 1. So 15 minus 2 plus 1 is 14. So there's 14 terms. So I'm doing all of this because in this arithmetic series, the formula is S sub n equals n over 2 times a sub 1 plus a sub n. So we're trying to find the sum of the 14 terms. So sum of the 14 terms is 14 over 2, because n represents the number of terms, times the first term, which we found was -1, plus the last term, which was 38. So plugging this in, I'm going to get 259. So the sum is 259 of the sequence. So the series is 259. 25, evaluate the series for the first 20 terms. So I need to figure out what type of series is it. In this case, it's arithmetic because it's going down by 2. So I'm going to use this same formula I did right here. So the sum of the first 20 terms is going to be 20 over 2 times the first term, which is -50, plus the 20th term. Okay, in this case, I don't have the 20th term. So it doesn't tell me what the 20th term is, but that's okay, because I can use the explicit formula of an arithmetic sequence. So the 20th term is going to be a sub 1, which is -50, plus 20 minus 1, times the common difference, which is -2. So -50 plus 19 times -2 is -88. So the 20th term is -88. So I need to put this here in my formula. So sometimes you have to use two formulas to get to the right answer. So -50 plus -88, the sum of this sequence is -1380, and that's called evaluating the series. Okay, 26. Determine whether each series converges or diverges. So this is a geometric series. I'm going to show you why here. So if I to figure out the first term, I would plug in n equals 1. So 5 times 1/4 to the 1 minus 1. 1/4 to the 0 power is 1. So 5 times 1 is going to give me 5. The second term is plugging in the next number, which is n equals 2. So that's going to be 5 times 1/4 to the 2 minus 1 power, which is just going to be 1. So this is just going to be 5 times 1/4, which is 5/4. To get the next term, that I'm going to plug in 3. So this is going to be 5 times 1/4. 3 minus 1 is going to be squared. So 1/4 squared is going to be 5 times 1/16. So this is going to be 5/16. So what's going on with my sequence is I have a 5, I have a 5/4, and a 5/16. So the numerator is staying the same, but the denominator is being multiplied by 4. So that's the same thing as a common ratio of 1/4. Another way you can find the common ratio is just take 5/4, which is the second term, and divide it by 5. So you get 1/4. So the reason I'm looking at my common ratio, R, is because I want to see, R tells me whether an infinite series, so this is infinite, converges or diverges. So the definition is if you have a geometric infinite series and the common ratio is less than 1, then it converges. So converges means it has a sum. If you added up all of the numbers in this sequence, you would get a number. It's kind of abstract to think about, but the problem I did in class was remember, if we have this area of 1, and then we add, well, actually this would be area of 1/2, and I add it to then this area, which would be 1/4, and I add it to this area, which would be 1/8, and I keep adding it, 1/16, you can see that I end up having an area of 1. So that's called converging when it actually goes to a sum. So if the R is less than 1, the absolute value of it, because it can also include negative, then it converges. And if the absolute of R is greater than or equal to 1, it diverges. So if it converges, it has a sum, and you can use the formula a sub 1 over 1 minus r. So I already figured out my a sub 1. That was 5. And my r I already know is 1/4. So just make sure that you're careful about putting this in your calculator. If you put it in your calculator, you can do it by hand. So 5 divided by 1 divided by 1/4 is going to be 6 2/3. So I want to answer as a fraction because the problem had a fraction in it. Okay, so answer as a fraction. So 27, we're doing the same thing. So we're figuring out if it converges or diverges. So in this case, my r is 3. So remembering that if the absolute value of r is greater than or equal to 1, it diverges. So if it diverges, you can't find a sum for it. It doesn't have a sum. If you added all of these numbers to infinity, it would never be a number. This ends up being negative infinity as an answer. So it doesn't go to converge to a true number. This is geometric, and the r is a half. So in this case, it converges. So if it converges, it has a sum, and I can find it because I can do a1 over 1 minus r. So a sub 1 is 12. R is a half. Just be mindful of calculating this properly using order of operations. So this is going to converge to, I started writing 8 because I put it in my calculator wrong, but I can tell already it's not 8 because it's already past 8. So this converges to 24.